Hello everyone, I'm Heitor, or Hector in English, and this is my video recording for the FENS Forum 2024 poster presentation happening in Vienna, Austria. And my work is entitled Stitching Cortices, a cortical surface reconstruction method for lesser known animals. And let's get started to it. So in comparing neuroanatomy, what we have is 3D reconstruction of cortical surfaces as a method of analysis, as it allows us to extract meaningful information about topology, geometry, and neuroanatomy for sure, like identification of gyri, sulci, and other cortical features that we might have interested in. But unfortunately, this method is mostly limited to humans and some other primates, and it's not really generalized to other species. So we need to actually expand this method for other lesser known species, and this is what we've been doing for the past year or so. The past year, we developed a Stitcher package, which is a software package aiming at reconstructing complex cerebral cortices, not only simple cerebral cortices, but also complex cerebral cortices. And Stitcher actually works directly with manual segmentation from the regions of interest. So we draw lines or contours, as we can see here in figure 1, which is a little bit of our pipeline. We start by drawing the parameters of interest. And from those parameters of interest, what Stitcher actually does, it takes a sequence of regions of interest and just connects the points belonging to one to the next one. And the criteria of connection is actually minimization of the total length. So what we want to do is actually find out what edge is the one that minimizes the path between those two. And also we have an extra condition that any given two edges, they cannot cross one another at any point. So with these two conditions, we actually created this software package, which allowed us to reconstruct complex and simple cortices. And we actually can do that even with partial data. So since the manual tracing is actually very labor intensive, we actually use only a fifth. So 1 out of 5 slices in the MRI image, we are actually manually tracing them, but we don't actually need the slices in between them to perform or to execute the Stitcher software. And we are actually able to get at least some results from those. And traditionally, what happens is that the surface is actually applied from the voxels and the pixels as pre-surface, the most common and popular tool for human reconstruction in cortical reconstruction. It derives the surface directly from the voxels, and we actually do an alternative approach. Instead of using the voxels, we allow the anatomist to overlay its expertise on top of the image by drawing these parameters. So from this, we are actually going to compare them what the results from our approach, Stitcher, versus a semi-automatic tool that actually compiles the pre-surfer, the most traditional tool, in a semi-automatic approach. And we are going to contrast these two results and see what we got from those. And we apply both Stitcher and pre-Reconal to 6 different species. Okay, so let's move on to the results. In the results sections, what we can see here is the Stitcher is indeed capable of reconstructing these complex brains and this complex brain morphology. And however, unfortunately, pre-recon fails in some cases. So let's analyze both. So half of the brains were properly reconstructed with both methods, meaning that Stitcher, which is on our left side here, and pre-reconal on the right side, were actually capable of generating meaningful data that we can actually use and analyze. However, unfortunately, when we get to more complex brains, more girified brains, such as both cetaceans and also the sea lion, unfortunately, pre-reconal didn't output any surface for us to analyze, and we don't actually have those surface to contrast with the Stitcher results. What we can see from both is that they are actually preserving the real anatomy of the brain. So the main cortical features are present in both of the reconstructions. However, we have some differences. So in the pre-reconal on the right, we actually have a surface that is a little bit more noisy in contrast with the Stitcher reconstruction, which has a much smoother surface. And this resembles a little bit more of the real cortical brain. Also, what we have, besides the difference in smoothness, is that pre-reconal, here on the right side, actually has some good definition and depth on the cell type, which lacks a little bit in Stitcher. And this actually might be caused by the lack of data that Stitcher is working with. Pre-reconal using pre-surfer actually segments the entirety of the brain, the MRI image, while, as I said before, Stitcher is working with 1/5 of the data, and this might actually be causing some of these structures to not be completely visible in the final reconstruction. So adding more manual labor might actually be the way to go to actually get more accurate brain reconstructions when using Stitcher. When you go to the more girified brains, what we have here is we actually get back those definitions and those depth in its entirety. And this actually corroborates the point that skipping 1/5 might actually be good in some cases, but not in others. Because since these brains are bigger, skipping 1/5 will actually still give us a lot of slices and a lot of data for Stitcher to reconstruct the brain, which might not be the case for smaller animals such as the raccoon, as we can see here. Another point that we have to address is that pre-reconal actually works as an adaptation of pre-surfer, and pre-surfer depends a lot on image quality and contrast. And in some of these image acquisitions, we might actually have some too much noise or too many artifacts that for the human eye, it's okay to simply draw over the image and just fix these image artifacts that might have occurred. However, for FreeSurfer, all it says is basically the image, and it doesn't use any or doesn't use much external knowledge to correct those artifacts. This might actually lead to an absence of a cortical region entirely, as we can see here in the bottom section of this reconstruction, which is missing a part. You can actually check all of our results scanning this QR code, and you will see a video of this actual 3D reconstructions on video so that you can see all of its sides and you can see the actual 3D aspect. So to conclude, the traditional approach has a little bit of difficulty with highly purified brains, and it's unfortunately still incapable of processing this data. We still need to investigate what are the main causes to this. It might be the palette of the images, it might be that something on the algorithm itself is just not working properly or as intended. Stitcher and anatomical expertise is actually a viable approach and a promising technique to overcome this issue, but also image artifacts. And finally, we have that Stitcher actually just shows us a possible pathway to perform surface-based analysis in other lesser-known species and just supplement the pure image approach that would just take an MRI and would not be capable of processing it any further. And that's it.